So let's look at the list of what are these core methods. Let's just, the simplest, straightforward is nucleic acid extraction, DNA extraction, RNA extraction. Typically, for most molecular methods for epidemiology or others, you need to do the first step, usually is nucleic acid extraction. Okay. If you are following the iTunes U course, I know some of you already registered since yesterday, I encourage you to do that. There is a detailed lecture. It's genomic DNA extraction, if it's plasmid extraction, alkali lysis method, how do you standardize those things. What is everybody is, I don't know, the principle usually is just the problem. Usually I know many graduate students, at least in our setting in the US or in my lab, we buy QIAGEN kit. It says AT buffer, AL buffer, elution, this. You can extract, right? But that is not really science to me. You need to understand what is really happening when you extract DNA out of a cell. What are you doing, okay? We can cover that quickly, but I have the lecture, but I know we have very limited time. I would rather focus on amplification, restriction, digestion, and sequencing this morning. But is everybody clear? What do you do when you extract DNA? What happens to the cell? You just suck it out of the nucleus or something? What happens? What is the first step usually when you extract a genomic DNA, let's say? Thank you very much. Remove the cell wall, cell membrane. Okay. What is the next? What happens then? Extract the nucleus. Is there anything happening before? No, that's a key big step. Okay. I know many of you know the answer, I think. Yeah, go ahead. Yeah. Remove proteins. There is a cytoplasmic component. Okay, to remove cell wall and cell membrane, what do you use? What? Okay, lysozyme. That digests what? Okay, you lyse cell, you can lysozyme. You use detergents to digest the lipids. You use what do you use to digest the protein in the cytoplasm? Protein SK, okay. And then, okay, now, okay, let's say it is with lots of junk material, the nucleic acid is exposed at least, and then you precipitate. What do you use to precipitate? How does DNA precipitate? Ethanol, very good. Alcohol precipitates DNA, okay. And then what do you do? That's a quick way of learning. That's good, I like this one. Okay. Okay, you wash, so you separate, okay, you precipitate your DNA, you separate, so in the detail there are many things, but okay, so you dry, you elute it, and you suspend it. Okay, very good. Just in simple terms, you do that. And then, okay, how do you measure your concentration of DNA? Photometry, spectrophotometer, very good. Nanodrop is a nice machine. Some people have nanodrops, some people may not have. Okay, but in principle, now let's focus not on a trademark of these companies. Absorbency at what wavelength? 260, wonderful. Okay, at 260, and then, okay, that's okay. You measure the concentration, right? If you have a reading of 1.0, what does that mean? How much DNA do I have?
50.
Thank you very much. Okay, 50 microgram per minute. That's very good. So you're understanding, okay? Okay, that's a concentration or how much DNA I have. But okay, I want to have a pure DNA. How do I measure the purity of my DNA?
260 relation with 280.
Okay, you take a ratio. I think that two people are very clear on principle. Everybody is clear. Okay, yeah, I encourage you to look at that lecture and just understand that yes, 8 to 60 to 80 ratio, and if I get this ratio of 1.7 around that area, it is pure. If I have too low, what happened? If I have very low ratios, there is a protein contamination. If I have too high, 2.8, what happened? RNA contamination, so you can, yeah, but I think, yeah, some people get it, but please understand, as a scientist, we need to understand the principle so that you can troubleshoot tomorrow if there is a problem. Your future graduate students have a problem, you should be able to address it. You can't just say, throw this, order a new QIAGEN kit. That's not the correct scientific solution. Okay, that's good. And then there is more, if you are doing alkali lysis for plasmid, there is specific principles. So please make sure to understand those principles, okay? But let's focus, so this material, again, you get it, but has all those the details of the nucleic acid, measuring, and then even you can extract your own DNA at home, by the way. That's